So what you see here on the table are different types of mounting media used for microscopy, and today in this video I want to make the case that especially if you're a beginner, you should be using these two types of glues here as a mounting medium and not the other ones that I have here because they have slightly more specialized uses. I will also go through each one of those mounting media here and talk about the advantages and disadvantages, and then I hope it's going to become clear why I prefer those two readily available glues as a mounting medium. But if you do not know what mounting media for microscopy are, well then I'm also going to very briefly explain that to you. Hi, hello and welcome, Microbehunter here. Let me clear off and clear the table here. What I've got here is a permanently mounted microscope slide of algae, and the specimen, a little bit difficult to see here now because it's so fine, is mounted beneath a cover glass using, in this case, this mounting media over here. It's called Elmer's PVA glue, and this slide now can be stored for a very long time. As a matter of fact, I made it over 2 years ago. Okay, so and what I'm going to do now is I'm going to go through these mounting media here, and I'm going to talk about the advantages and disadvantages, and then I'm going to try to make it clear why I prefer those two water-based mounting media here for general purpose work. Okay, so let's save those for the end. If you've been watching my YouTube videos in this channel and also in my other channel, then you know that I like to make permanently mounted slides using Euparal as a mounting medium. Now this mounting medium is used very often for mounting insects and other small arthropods. As a matter of fact, it's the standard mounting medium to use for insects. The reason is because it has a so-called built-in clearing action. In most insects are very dark, and this mounting medium makes them more transparent after a couple of days, and therefore it's much easier to observe them under the microscope. However, this mounting medium has a disadvantage, and that is, well, it's not quite as readily available and sometimes a little bit expensive. So you have to go to and try to get them from specialized shops, which might not even send them to private individuals. Now, I bought this mounting medium, look, a long time ago. It's still useful, even though actually the expiry date was already 2013, and it still works. When the mounting medium starts to dry up a little bit, then you can add a little bit of alcohol if you do not have the appropriate solvent. Alcohol does work, and this is another advantage. It allows you to transfer insects directly from alcohol into Euparal mounting medium. You basically catch insects, you put them into alcohol to remove the water, and then you can actually directly transfer it into the mounting medium, and it will work. It just takes maybe 2 months for the mounting medium to dry, but otherwise it's a very good and stable mounting medium. So, however, as I mentioned, not always easily available. So another mounting medium that I've been using a lot is this one over here, Eukitt. It's called Eukitt Classic. They have got different types of mounting media, but this one is the classic one. This was also one of my first mounting media that I used when I started off with microscopy long time ago, almost 30 years ago. And Eukitt is a very fast drying mounting medium, however has a very stable and is also used when slides are made commercially. So essentially because of its fast drying time, much faster than, for example, Euparal over here, which takes 2 months maybe to dry. However, Eukitt does have a significant disadvantage, and that is that you cannot simply transfer specimens from water and not even from alcohol into Eukitt. The specimen either has to be completely dry, free of water, free of alcohol, and this basically means that there's the possibility for shrinkage, or the specimen has to be has to be surrounded by a solvent called xylene, and this xylene is not healthy. So that is also a problem that the solvents, the organic solvents that are in here, the fumes, and you always have to use them in a very, very well ventilated surrounding. Otherwise, there is there are health hazards. So I always use Eukitt when I have the windows open, and I make sure that there is enough aeration or something like that. But that's, you see, it's not only the mounting medium, but also the specimen itself has to be in an appropriate solvent. So this is a very nice mounting medium, but again, only suitable if the specimen is completely dry. So I have mounted insects as well that are completely dry. However, not all specimens survive, in other under quotation marks, or this drying out. And when I say survive, then I'm talking about the structure, right? Another disadvantage that these mounting media with an organic solvents have is that they tend to dissolve pigments that can be found in the specimen. So for example, if you try to mount algae, which are green, or other plant materials, then the solvent will actually dissolve the chlorophyll, the green chlorophyll, and then the specimens are going to lose color. Yeah. So again, highly advisable if the specimen is suitable, but not suitable for all specimens, and also not quite easily available. So let's move on to a mounting medium that I've also been using quite recently. This is glycerin gelatin. And this one, as you can see, already contains a dye, a stain. This one is actually specifically designed to mount pollen grains, but can also be used to mount other delicate organisms. Glycerin gelatin is a mounting medium that does not turn completely solid. It stays in a semi-solid state. It's like a gel, very thick gel. And this, the advantage of this one is that you can mount also delicate water organisms because it's a water-based mounting medium. So for example, algae, also in this case pollen, for example, are very sensitive to drying. And in this case, you want to use this one here as a mounting medium. However, big disadvantage, very difficult to use. What you have to do is you have to actually melt the mounting medium on a hot plate or warm plate, no, not hot plate. If it's too hot, then you're breaking the medium, so you have to heat it up to, let's say, about 40 degrees centigrade, and then this will melt the mounting medium. You have to put a cover glass on top, and not only that, I'm just also going to show you, I've mounted some slides here using this. You also have to put a ring around it using nail polish to prevent it from actually drying out. Yeah, so this is, you see that this is not enough simply to mount the specimen, but you also have to put a ring around it. This means you have to use round cover glasses. So you see, it's complicated, right? But in some cases, this is indeed the standard mounting medium to be used for mounting specimens. So for example, if you're into studying pollen grains from plants, that's the one that you're going to be using. That's the standard one to use. Yeah, so you see advantage, delicate water organisms and pollen can be mounted. Disadvantage, very difficult to use, lots of bubbles if you're not careful, okay? So let's move on now. This one over here, I've been experimenting with, okay? This is simply clear nail polish and forget about it. Doesn't work properly. This is basically a mounting medium that I've tried experimentally. Has the disadvantage that it really shrinks a lot when drying, okay? So it really shrinks a lot, and this means lots of bubbles. And you also the same issue as over here with Eukitt. The specimen has to be completely dry, or be in this case maybe embedded in surrounded by acetone, which is basically also a nail polish remover. So you're gonna say, if it's so unsuitable, why am I even mentioning it? Right? Why even talk about it? Well, because it does have one highly specific use, and that is if you want to, now bear with me, you're not going to believe this, if you want to actually make photographs of snowflakes. Okay, now you have to, you're surprised. What you do is the following. You basically apply this nail polish mounting medium on a microscope slide. Okay, you basically first you have to freeze it, right? You put it into a freezer. It's not going to freeze. It's not going to turn solid. And then you place the ice cold nail polish on an ice cold microscope slide, and you catch some snowflakes. And the snowflakes will leave an impression in the nail polish. And then when the snowflake melts away, then you can actually observe the impressions that the snowflakes left behind. yeah, looks nice and has a highly specific use. That's the reason why I'm basically talking about this. Otherwise, nail polish is used to actually make those rings here, and that is actually the very common use. Okay, so now let's move on. Now let's move on to the two mounting media, or to this one mounting medium that I actually wanted to recommend. This is called Elmer's PVA glue. Be careful. There are different versions of this. This one you have to get the clear version. Many of those glues are actually white. Right? You don't want to have that. And the advantage of Elmer's PVA glue is it's extremely cheap, fairly readily available, not quite as common as the white one, but so you have to look around, right? And also it's water-based. So this means that you can take specimens that are have been in water, you remove any excess water, and you can basically directly mount the slide using this Elmer's PVA glue. Now this Elmer's PVA is commonly sold in the United States, in Europe, maybe also in the US, I don't know, but at least here in Central Europe, where I am right now, we have this glue over here. It's called Uhu, and there are also different versions of this. One of the standard one contains acetone, and it's much thicker. But this one over here it says here, free of solvents. Well, of course, it has a solvent. It's water. So it's a water-based glue, and apparently, according to my research, it also contains PVA. So the chemical composition of those two is quite similar. Now, what I have, however, done is the following. And for this reason, I have now taken some of this glue, kind of filled it into a glass bottle like this, and added a little bit of water to dilute it down a little bit. How much water? I don't know, maybe 10%, 15%. I just estimated it. And then you have to properly mix it. You have to be, again, careful that you don't shake it too much, otherwise there are bubbles. And then you let it rest for a couple of days for all of the bubbles to disappear. And then you get a very liquid PVA glue. And if you dilute it too much, then of course this water, the water will evaporate, and there might again be problems of shrinkage. However, I have had very good experiences with this Elmer's PVA glue. And as a matter of fact, this is actually also the glue, this one over here, that I used to make this microscope slide over here. Yeah, and we're going to have a look at it under the microscope right away to actually, I want to show you how well the slide has been prepared. This one over here, I've also been using a little bit, and it's can also be diluted down with water. And what I have done is I've also mounted some specimens directly from this bottle. I've simply applied a drop on the microscope slide, put a cover glass on top, pressed that down on it, and that also worked. Okay, maybe sometimes if you want to mount larger objects, you might have to put a second drop on top, and then you simply press down. And if there's any mounting medium spilling out, then you just let it dry. So that's basically the case that I wanted to make here. But as promised, let's have a look at this slide here first. Yeah, these are algae. The large circle, of course, is an air bubble. You cannot avoid those at all times. However, you can actually see that the colors have been properly retained. This would not be the case had I used a mounting medium with a solvent. Then the green color of the algae would have disappeared. They would have been washed out into the medium. Let's go up with the magnification. So I'm now using a 20x objective, and you can see over here that those algae still look quite nice. How did I prepare those? I added a sample to the microscope slide and allowed the water to evaporate, and then I placed a drop of this PVA glue on it and the cover glass, and here we are, right? And that's basically a sample that I prepared 2 years ago. Right. So further magnification, 40 times objective. My recommendation, however, is that you do not dry the sample completely. Just make sure it's still a little bit moist. Otherwise, you might have more possibilities of air bubbles. So if it is, the water should be gone, but the sample itself should be a little bit moist, you can determine that by holding it a little bit into the light. You drop then the PVA glue mounting medium on top of it, and the cover glass, and then over the next couple of days, as the glue dries, the glue will also infiltrate the specimen and will also stabilize it from the inside. So the specimen itself is not going to be completely dried. I once dried it completely, and then there were more air bubbles also inside the individual cells. I would now like to mount these specimens over here on a microscope slide. These are cross sections of oak wood, now basically not in paraffin but in glycerol. And glycerol and PVA glue, they are compatible to each other. That's the good thing. And then we're going to, of course, also have a very quick look under the microscope. What I'm going to do first is I'm going to, of course, put a small drop of this PVA glue. Yeah, on the slide. You see it's fairly liquid because I diluted it with water. So I'm going to now transfer one of those cross sections into the glue. Here it is. Of course, I have to now clean also the tips of the tweezer. I have to make sure that it's fully submerged. Yeah, if not, I'll have to add another drop on top. And I think it is fully submerged, and I'm now going to add the cover glass. I'm going to allow capillary action to do the rest. Of course, I can also press down slightly, and I hope that most of the bubbles are going to be gone. Okay, but now next thing that you have to be careful is if there is any glue spilling out from beneath, just be careful that you do not contaminate your microscope objective, especially if you're using high magnification. So the best idea would be to just leave it now for a couple of days. However, I'm not going to be that patient. I'm going to show it to you right away. We're now looking at the edge of the specimen, so where it's very thin, and you can see that yeah, the individual cells are quite nicely visible over here. Let's quickly have a look. This is not bright field. Let's quickly have a look now how this looks in phase contrast. Yes, this here is now in phase contrast as well. One disadvantage, and that's not, the glue is not to blame for that, but there is one disadvantage. I did not properly prepare the specimen, and for this reason, there are, of course, many air bubbles still present between the cells, which you're able to see here. Yeah, but that is not a problem of the mounting medium, but rather the fact that I did not apply a vacuum on the specimen to remove those air bubbles. But that is, I think, the topic of a completely different video. I hope that you found this video here informative, and yes, share your own thoughts and experiences. There is a comments section below, but for me, that's all I will have for you today. I would like to invite you to subscribe to this channel, of course. Happy microbe hunting as always, and see you in the next video. Bye bye.